This is the pre-lab video for the Molarity and Dilutions lab. In this lab, you are going to make 50.0 milliliters of a 0.0500 molar sugar stock solution in a volumetric flask. You are then going to take that stock solution and make 4 dilutions from it to 0.04, 0.03, 0.02, and 0.01 molars. And I will go over the math for that in a little bit. A stock solution is a relatively concentrated solution that you use to make dilutions from. So the stock solution is always the most concentrated one out of the batch. Imagine if you are a chemist and you're reading a procedure that says you need 1 molar hydrochloric acid, but all you have is a 10 molar hydrochloric acid solution. Well, you don't want to just use that 10 molar. What you have to do is dilute it down to 1 molar, and that's what we're going to end up doing in this lab, but we're going to use a sugar stock solution that you make up. When you are making a stock solution, you use a volumetric flask. Now in this case, the volumetric flask is 250 milliliters, and on any volumetric flask there is a line on the neck somewhere. So that dark line that is right there, when you have the liquid filled up and the meniscus reaching that line, that is telling you that you have exactly 250 milliliters. So when you are using a volumetric flask, what you have to do in this case is figure out how much sugar you have to add to the volumetric flask. So I always dump in the solid first, because if you want the meniscus to go up to this line, if you put the liquid in up to that line and then dump in the sugar is going to displace some of that liquid, and the meniscus is now going to go above the line, which we don't want. We want that meniscus right on the line. So you have to calculate how many grams, and I said I'll help you with that in a minute, how many grams of sugar go into this volumetric flask. Now we are also going to use food dye. You want to add in 1 drop of food dye, because that is something that will help you answer questions at the end. So what I do is dump in the solid, add the 1 drop of food dye, add water so it's like most of the way up this curved part. And I only added up to that part at first because now when you shake it, there's plenty of room for the liquid to move around, and it should help that sugar dissolve. Just be careful when you're shaking it. Use 2 hands. And then once you have that mostly dissolved or all the way dissolved, you add water up to this line so the meniscus is at the line. Now once you have it at that point, I would then put my finger over the top, basically to stop the liquid from falling out, and invert the volumetric flask a couple times. Since all you're using is water, sugar, and food dye, nothing is toxic at all. It doesn't really matter if you get a little bit of that liquid on your skin, but you just want to turn it upside down a couple times just to make sure it's evenly mixed. Now, in reality, if you wanted to make very precise dilutions, you would then use smaller volumetric flasks to do that. So what you're going to do, once you have your stock solution, you're going to do a little bit of math using this equation, M1V1 equals M2V2, to figure out how many milliliters you have to take out of this stock solution to then dilute to these lower concentrations. So in the lab, it's telling you that you're going to end up making 4 different dilutions that are each 10 milliliters. So let's just say, for example, that when you do the math, it says you need 1 milliliter of this stock solution. What you would do is take out 1 milliliter, add it to the test tube, and now you should be able to do a little bit of easy math to figure out how many milliliters of water you have to add to dilute it up to 10 milliliters. And then you should be able to get that concentration right on. That is the idea behind this lab. Now I'll show you how to do a little bit of the math.
I'm going to go over some examples of what the math will be like. The numbers and the chemical are different, but the general setup is the same. So let's say I wanted to make up a 250 milliliter stock solution that is 1.5 molar, 1.50 I'll use, and that's going to be sodium chloride, so that's NaCl. Well, the equation you start off with is molarity equals N over V. And remember, N is moles, volume is liters. So what you have to do is rearrange that equation for N, and what you get is N equals N times V. Now what I'm going to do is, instead of writing just capital M for molarity, I'm going to write it as moles per liter, because then that will help you help to remind you that instead of 250.0 milliliters, you have to convert that to liters, because you need the liters to cancel out. So that's going to be 0.2500 liters, because you need liters to cancel out. When you multiply that, what you get is 0.375 moles of NaCl. And now what you have to do is take that 0.375 moles of NaCl and multiply it by the molar mass. What happens is in 1 mole of sodium chloride you get 58.5 grams, and that is per 1 mole. And we're talking about NaCl here. Now when you multiply that out and round it off, you get 21.9 grams of NaCl. That is how much you would have to put into the volumetric flask, and then you add 1 drop of the food dye and you add water up to the line. Now that's how you make the stock solution. To make the dilutions, say I wanted to now make a 50 milliliter solution that is only 0.750 molar. Well, we started off with 1.5 molar, and I can't just use that. I have to now dilute it to 0.750. So the equation you're going to use is M1V1 equals M2V2. The stock solution is what we'll do for 1. So the molarity of the stock solution was 1.50 molar. What you're solving for is V1. Molarity 2 in this case is 0.750 molar. And V2 we want is 50 milliliters. So when you do the math for this, what you get for V1 is 25.0 milliliters. So what that's telling you is you would have to take 25 milliliters out of the stock solution, add it to another volumetric flask, but in reality you're using a test tube, and add water to bring it up to 50 milliliters, and then you would have 0.750 molar of that sodium chloride solution.